Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discussing Clairaut's equation, problem based on Clairaut's equation. So one more important problem. Observe carefully. Reduce x into y p square minus x square plus y square minus 1 into p plus xy equal to 0 to Clairaut's form and find its singular solution. Okay, so this is the problem. So from the second unit, so this Clairaut's equation is the last concept from the first half part. Definitely we'll get one essay question from this concept of Clairaut's equation. So previous lecture we discussed one problem based on this method only. So now we are going to discussing another problem. Why? Because previous problem is about general solution. So how we can find the general solution by using Clairaut's equation. In this problem we are going to discussing singular solution. I also explained singular solution is nothing but in the final solution there is no arbitrary constant. That solution is called a singular solution. You can observe that, Amma. So first of all, see that the given differential equation is x into y p square minus x square plus y square plus 1 into p minus xy equal to 0, taking as equation number 1. Okay, so we are going to find the singular solution by using the Clairaut's equation. So first of all, we have to convert this differential equation into Clairaut's form. To convert Clairaut's form, Amma, so definitely we have to take the aid of two substitution functions. So that substitution function aid is nothing but let x square is equal to small u and y square is equal to small v. Okay, in the previous problem we have assumed that y is equal to small u and x into y is equal to small v to convert the given differential equation into Clairaut's form. Now to convert the present given differential equation into Clairaut's form, so now we are going to taking help of x square is equal to small u and y square is equal to small v. Now differentiate above equations. Above equations means these two equations. Differentiate above equations. So x square is equal to small u. No? So if you differentiate with respect to x, so therefore with respect to u, dx 2x into dx that is equal to du and differentiate with respect to small v, y square equal to v. So 2 into y dy is equal to dv. When you differentiate x square is equal to u with respect to u. So for x square 2x is the differentiation. Again for x dx by du with respect to u equal to in RHS u differentiation will become 1. Okay. So send this du value to RHS, then you will get 2x dx is equal to du. Similarly for the y square is equal to v also. Dividing above equations, divide that LHS value separately and RHS value separately. The next step is also same. So therefore 2y by dy, 2 into y dy by 2x into dx equal to dv by du. So here 2 will get cancelled. Okay, so remaining value I am writing y by x dy by dx is equal to dv by du. So y by x into you know very well dy by dx small p, dy by dx is equal to small p. Na? So I am writing that value small p and dv by du capital P. So therefore capital P is equal to dv by du. From that value, so we required small p value. So send this y by x value to RHS, then small p is equal to capital P into x by small y. So that is taking as equation number 2, small p is equal to p into x by small y. So where small p is equal to dy by dx. After getting that small p value, so that is taking as here equation number 2. Substitute in that equation number 1 wherever you have small p. Okay. So therefore substituting equation number 2 in equation number 1. So therefore x into y, so wherever you have small p, substitute that value x by y into capital P whole square minus x square plus y square minus 1 into x by y into capital P plus x into y is equal to 0. After substitution, now simplify x into y, x square by y square into capital P square minus x square plus y square minus 1 into xy by into capital P plus x into y is equal to 0. We are just substituting that small p value in equation number 1 and again simplify, you will get that value x cube into, here you have x into x square, so therefore x cube and 1y will get cancelled, x cube by y into p square minus x square plus y square minus 1 into x by y into capital P plus x into y is equal to 0. Now take small y as the LCM amma in LHS. X cube into p square minus x square plus y square minus 1 into x into p plus xy square equal to 0. You know very well how to take that LCM process. You have to multiply each fraction with that LCM value. So send this y value to RHS, then that value equal to 0. Then LHS is equal to x cube p square minus x square plus y square minus 1 into x into p plus xy square equal to 0. Now take small x value common, okay, from that above equation. So take small x value. Why? Because small x is involved in each and every term, no? So therefore take small x common. So x into x square p square minus x square plus y square minus 1 into p plus y square equal to 0. Okay, so if you take x is equal to 0, okay, if you take x is equal to 0, so where x is if you take x not is equal to 0, why? Because where x is a variable, so variable is always not is equal to 0, then automatically, so this value will equal to 0. Okay, x square p square minus x square plus y square minus 1 into p plus y square equal to 0. Okay, so therefore next since we have considered x square is equal to u and y square is equal to v na, so now resubstitute those values here. So therefore wherever you have x square amma, substitute u, wherever you have y square substitute v. So u into p square minus u plus v minus 1 into p plus v equal to 0. Now simplify with the simple sum. So therefore up square minus up plus minus vp plus v equal to 0. Minus into minus plus summa plus into p. So therefore now from the first two terms take u into p common. Okay. So u into p if you take common, from the first term p will come and the second term minus 1. Okay. So if up is the common number, so therefore p minus 1. From the minus vp and plus v term, minus vp plus v term, take minus v common, again you will get minus v into p minus 1 and the remaining term is plus capital P equal to 0. Again you have p minus 1 and p minus 1 common, take p minus 1 common, then remaining terms u into capital P minus v plus p is equal to 0. So therefore p minus 1 u into p minus v is equal to, if you send this p value to RHS, it will become minus p. Okay, so therefore up minus v is equal to, send this p minus value to RHS, then it will goes to the denominator of minus p. So minus p by p minus 1. From that equation, send this minus v value to RHS and take that negative value to LHS. So therefore then you will get v is equal to up plus p by p minus 1. That is taking as equation number 3. Which is the Clairaut's equation? Equation number 3 is in the form of Clairaut's equation. You know very well Clairaut's equation, it always exists y is equal to p into x plus f of p format. Okay. So here you have y square equal to v na. So here you have v and u in terms of variables. So v is equal to u into v plus p by p minus 1. Which is the Clairaut's equation in terms of u and v. Now differentiating equation 3 with respect to small u. What they are asking, find that the singular solution. To find that singular solution, we have to eliminate that the arbitrary constants. Okay. So therefore to get that arbitrary constant summa, so therefore apply that first differentiation, dv by du is equal to, for the first term up you will get 1 into p plus u into dp by du plus second term p by p minus 1, you can apply the d by dx of u by v formula. So therefore you know very well v into u dash minus u into v dash by v square. Okay. So d by dx of u by v formula you know very well. So v into u dash minus u into v dash by v square. By applying that formula you can simplify that value, and after that p is equal to dv by du, it is capital P in LHS. In RHS it is also 1 into p capital P plus u dp by du plus p dp by du minus dp by du minus dp into dp by du by p minus 1 whole square. Okay, on both sides this p will get cancelled. So therefore, so p minus p equal to u dp by du minus 1 by p minus 1 whole square into d small p by du. So therefore, pp will get cancelled in LHS 0. 0 is equal to u into dp by du minus 1 by p minus 1 whole square dp by du. Okay, so now take dp by du common from the two terms in RHS. So therefore, I am writing in this format u minus 1 by p minus 1 whole square dp by du is equal to 0. So now consider this value, amma. Consider that value u minus 1 by p minus 1 whole square equal to 0. Okay, so why? Because to apply that Clairaut's equation, amma, so always dp by du, if you take dp by du equal to 0, okay, then you will get p is equal to any arbitrary constants. But here we are proving with respect to singular solution. So to get that singular solution, amma, we are not taking that term dp by du is equal to c. If you take dp by du is equal to 0, you will get p is equal to c is again arbitrary constant. But in the singular solution, there is no arbitrary constant. So that's why we are taking this second box. Okay, so therefore u minus 1 by p minus 1 whole square equal to 0. From that condition, send this negative term function to RHS, then u is equal to 1 by p minus 1 whole square. Okay, so make reciprocal, amma, u will become 1 by u and 1 by p minus 1 whole square will become p minus 1 whole square. So apply square root on both sides. Okay, apply square root on both sides. Then in RHS square root will get cancelled. Then in LHS 1 by root u is equal to p minus 1. So therefore, from that condition you have small p is equal to 1 by u plus 1. 1 by root u plus 1. Okay, small p is equal to 1 by root u plus 1, taking as equation number 4. Now substitute that equation number 4 in equation number 3. Okay, what is that equation number 3? Equation number 3 is the form of the Clairaut's equation. Okay, so wherever you have that p value, substitute from equation number 4. Then you will get in this format, v is equal to u into 1 by root u plus 1 plus 1 by root u plus 1 by 1 by root u plus 1 minus 1. Okay, here plus 1 minus 1 will get cancelled. Okay, so therefore v is equal to, if you take that LCM, amma, inside that box you will get to u by 1 by root. Otherwise you can multiply u with that box. So therefore u by root v and 1 into u is equal to u only plus in the numerator take LCM 1 plus root u by root u by in the denominator 1 by root u. Okay, again root u will get cancelled, amma. So therefore write down v is equal to, so v is equal to, here you have u by root u. So u by root u means if you cancel, amma, how you can write u? Root u by root u by root u. So one root will get cancelled, you will get a root u plus u as it is plus 1 by root u remaining value from the numerator. So therefore v is equal to root u plus root u 2 root u plus remaining value is u plus 1. So substitute, since we have v is equal to y square and u is equal to x square. So therefore wherever you have v, substitute y square. Wherever you have small u, substitute x square. Y square is equal to 2 root x square plus x square plus 1. So square root will get cancelled. So therefore y square is equal to 2x plus x square plus 1. So therefore y square is equal to, if you write in this format, amma, x square plus 2x plus 1. So it is purely in the form of a plus b whole square. That means a square plus 2ab plus b square. So that means I will write y square is equal to x plus 1 whole square. So x plus 1 whole square is, if you again split that value, amma, you will get this value only, 2x plus x square plus 1 only. So therefore this is the required singular solution of equation number 1. Okay, that is only they are asking, y square is equal to x plus 1 whole square. So you can observe there is no any arbitrary constant. There is no c value. There is no any arbitrary constant in the final solution. Y square is equal to x plus 1 whole square. There is only x and y variables. So therefore these types of solutions are called singular solutions. By using that Clairaut's equation, final solution we can express in terms of general solution. In general solution you will get variables along with arbitrary constant. In singular solution there is no arbitrary constant, only variables will be there, x and y. Okay, so that is the difference between singular solution and a general solution by using the Clairaut's equation. So This is the total explanation of this problem, Amma. I hope you understood this problem very well. So in the next lecture, we are coming with the second half part of that unit, that is the applications of the differential equations. So make a perfect practice, prepare well. Until bye. Thank you.